I will discuss the graph theory. You know, in the circuit theory, to know the voltages and currents, we use the Kirchhoff's laws, that they are nothing but Kirchhoff's voltage law and Kirchhoff's current law. The same method or the same results we can also obtain using the graph theory. In this graph theory, we obtain the matrices, and from the matrices we get the desired voltages, desired currents at desired places. To discuss the graph theory, let me divide into three parts. One is the fundamental part, next tree, the next is cut set. So in the first case, network, branches, nodes, graph, oriented graph, incidence matrix, reduced incidence matrix. Network means it is nothing but circuit consisting of several passive elements and active elements like this. This is the circuit where we have the passive elements, all resistors connected like this. There is a term called network topology. It is nothing but the study of the properties of a network. Branch means, so in the network, if the elements are replaced by a line like this, then we call that is a branch. If the element is ideal current source, we have to replace that with open circuit. If the element in the branch is ideal voltage source, replace with the short circuit. If the element is passive element, just short circuit or show with a line. Then what is graph? Graph is nothing but a network in which nodes are represented with dots and branches are replaced by a line like this. So this is one node, this is another node, this is another node, this is another node. Subgraph. When some branches are removed from the main graph, then the resultant graph is called the subgraph. Then oriented graph or directed graph. This shows when the arrows placed on each branch of the graph with certain direction, that arrow normally represents the direction of current or polarity of the voltage source. Then such graph is called the oriented graph. So like this, we can assign a direction for each branch in the graph like this. Then this is called the directed graph or oriented graph. Then path. This is another term which we use here. Sequence of branches from one node to the other node is called the path. There are again two types of graphs. One is called the planar graph. This is also called planar circuit. Suppose we have the electrical circuit like this. Then we can replace each passive element with a line like this. Then this is called the graph. This is called the planar graph. Next, non-planar graph. In the non-planar graph, this circuit will be shown like this, in which we find the crossovers. This is a one crossover. Whereas in the planar graph, we did not see the crossovers. Whereas here in non-planar graph, we find the elements with crossovers like this. Once we draw the graph for this, we get the crossover like this in the graph also. This is the network, this is the graph. This type of graph is called the non-planar graph. Next we see incidence matrix. It is nothing but a two-dimensional matrix which provides information orientation of branches in a graph with respect to the nodes of the graph. The properties of the incidence matrix are like this. Mark the nodes of the graph by numbers 1, 2, 3, 4, etc. and branches of graph by lowercase letters A, B, C, D, etc. Next, draw the graph and place arrow mark to obtain the oriented graph. Next, third step is prepare a table as shown below. In the table, the branches are listed in the column and nodes in a row. Fourth step is at the intersection of row and columns, write the incidence of branch to the node by putting 0 or +1 or -1 in a manner as shown below. The fourth characteristic is at the intersection of row and column, write the incidence of the branch to the node by putting 0, +1 or -1 in a manner shown below. The fifth one is every column has two non-zero elements, one of which is +1, the other one is -1. Sixth property is the sum of the elements in any column is 0. Seventh property is the rank of this matrix is always n minus 1, where n is the number of nodes of the circuit or graph. The eighth property of the incidence matrix is its determinant is 0. The format for incidence matrix, as I said above, so here we find the nodes, whereas here we find the branches. So nodes 1, 2, 3, 4 like that. Here we get the branches A, B, C, D, E, F like that. Next, reduced incidence matrix. Removal of one row from the incidence matrix is called the reduced incidence matrix. To understand this incidence matrix formation and reduced incidence matrix, so let us take a problem like this. This is the network where we have a voltage source in one of the branch, and in another branch we also have the current source connected in parallel with a resistor, and the remaining elements are passive elements. They are nothing but resistors. For this circuit, find the incidence matrix. So to get the incidence matrix, the first requirement is to get the graph, that is oriented graph. So this is the circuit and we know the rules. To replace the voltage source, we have to short circuit it, whereas to replace the current source, we have to open circuit the current source. And the passive elements should be replaced by a straight line or simply line. So once we draw that, we get the graph like this. This is the current source. As per laws, it should be open circuited, so it is open circuited, and this is the voltage source. It should be short circuited, so it is shown with the dot short circuit here. And this element is resistor is shown with a straight line or line. Similarly, this is a resistor, this is another resistor. Both are represented by lines like this. Similarly, this is another resistor replaced by a small line like this. Similarly, this resistor is replaced with the line like this, and this resistor is replaced by a line like this. So this is nothing but graph of the given network. So this further we can draw neat diagram like this. So here the nodes are represented with the dots like this, here, 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 here. And now give the names for this nodes and similarly to the branches. This is the node 1, so put 1 here. This is the node 2, so put 2. And this is node 3, so put 3 here. Then this is the node 4, so put 4 here. And this branch is A branch, so put A here. This is another branch, so put it as B. And this is another branch, put as C. And this branch is E. And this branch, call it as D. And this branch, call it as F. So we obtained the oriented graph for the given electrical circuit. Once oriented graph is obtained, we can write the incidence matrix without much difficulty. So after getting this oriented graph, we have to find out what are the branches connected to each node, what are the branches not connected to that node. Here this is node 1, so make a column like matrix like this. For node 1 connected branches A, D, C. And to the node 1, the disconnected branches are nothing but B, E, F. Write like this. So these elements are going to be replaced with the 0. Whereas for this, we put plus 1 or minus 1 depending upon the orientation of the current in the branch with respect to the node. If the current goes away from the node, we put as 1 plus 1. If the current flows towards the node under consideration, then we put as negative. Similarly, for node 2, the branches connected are ABF, ABF, whereas other elements are not connected. That is nothing but CDE. So these elements are going to get the 0 in the matrix, whereas these elements are going to get the 1 with plus or minus 1 sign. Similarly, for node 3, the connected branches are BCE and rest are disconnected elements. Next, for the node 4, the elements connected are DEF and rest are disconnected, that is ABC. Now let me write the incidence matrix following the rules mentioned above. First take the node 1 and we have seen the what are the disconnected branches. Disconnected branches from for node 1 are nothing but B, F, E. So put those elements as zeros like this, B, E, F are zeros. Then connected elements are A, D, C. A is going away from the node 1, so put plus 1. Similarly, C also current flowing to branch 3 is away from the node 1, so put here plus 1. Whereas branch D current flows towards the node 1, so put it negative here. And this completes the node 1 incidence matrix. So next, node 2, this is the node 2. The branches which are not connected to this node we have to identify, then replace those elements with 0. So if you look at this, the elements not connected for this is nothing but C, D, E, C, D, E. So go to those places and put 0, C, D, E. And rest of the elements are connected to this node 2, that is B, A, F. So take the A. This A current flowing towards the 2, so put minus here, whereas B, current flowing away from the node 2, put plus 1. Similarly, F, current is going away from the node 2, put plus 1 here. Similarly, node 3, what are the elements disconnected to the node 3? This is the node 3. Elements disconnected are nothing but A, D, F. A, D, F. So for these elements, put zeros. A, D, F. A, D, F. Next, what are the elements connected for this? Element B, branch B, that current is flowing towards the node 3. So put minus here. So no branch 3 current is also flowing towards the node 3. Put minus 1 here, or C. Next, we have another element called E. This element current E is flowing away from the node 3, so put plus 1 here. Similarly, for fourth row, that is node 4, first identify the disconnected elements or branches. The disconnected elements for the fourth node are nothing but A, B, C. A, B, C. These three elements are not connected to the branch 4. Then put their values 0 in the matrix A, B, C. Corresponding to A 0, corresponding to B 0, corresponding to C 0. And what are the rest of the elements? They are connected. Element E is connected. Element E current is flowing towards 4, so put minus. Similarly, element D current is flowing away from the 4 node, so put plus under D, plus 1. Similarly, F is there. This F element current flowing towards the node 4, so put minus there. So current leaving the node we put as plus, current entering the node as negative 1 or minus 1. So this incidence matrix represents the relation between the nodes and the branches, their orientation, means current direction. Coming to the reduced incidence matrix, that is nothing but removing one of the row from the incidence matrix will result in reduced incidence matrix. The specialty of the incidence matrix is calculation of the sum of the column elements results in 0. This is plus 1, minus 1 added to results in 0, plus 1, minus 1. When you add those again you will get 0 here. Similarly, plus 1, minus 1 we get 0 here. Here for this column minus 1 plus 1 results in 0. Then here also plus 1 minus 1 results in 0. Similarly, F column plus 1 here minus 1 here. The resultant is 0. This is the beauty of the incidence matrix. So once we get the results for each column as 0, then we say that incidence matrix is right. Otherwise we have to check it. And there is another quality of the incidence matrix, that the determinant of its matrix is 0. Once we remove the last row of the incidence matrix, then we get the reduced incidence matrix like this: plus 1, minus 1, 0, plus 1, minus 1, plus 1, 0, minus 1, minus 1, 0, 0, 0, 0, plus 1, 0, plus 1, 0. And here we cannot say the column total is 0. Sometimes it will be 0, sometimes some columns it will be different. It will be like this. Here it is 0, here also 0, here also 0, whereas here it is not 0, that is minus 1, whereas here it is not 0, again plus 1. Here it is not 0, it is 1. So let me summarize once. We have seen what is network, that is nothing but consists of several passive elements and active elements. Branches means that is nothing but each branch will have passive element and the active may have active elements also. And nodes means they are nothing but the connecting points between the two or three elements. Graph means it is nothing but a representation of all the branches with lines. Oriented graph means so that shows the representation of all the elements in with the help of lines and with current direction for each element. And we also saw what is path. We also saw what is planar graph, what is non-planar graph, and we have seen what is incidence matrix and how to get the incidence matrix. Also, we observed similarly. We have seen the reduced incidence matrix. So we have seen how to get the incidence matrix by following the procedure for a given circuit. If the graph is given, we have to give the orientation. If the circuit is given, we have to get the first graph, and from that graph we have to write the what is called the orientation graph. And after orientation graph, we have to put the names for each branch, and also for each node we have to put the numbers, keeping dots at every node. And after that, by following the rules for the incidence matrix, if the current flowing through the element connected to the node is towards the node, we put as minus. If the current flowing through the element away from the node, then we call that as S1. And whereas if the element is not at all connected to the node, then we put as 0. So following all these rules, we obtained incidence matrix, and after that we obtained reduced incidence matrix. So basically incidence matrix represents the relation between the node